Hello and welcome to my channel and the second video in the Case Against the Flat Earth series. In this second challenge, we will determine the elevation angle to Polaris from your location, then apply some basic math to your findings and determine the distance of Polaris from Earth on a flat Earth model using the data that you provide. First things first. If you haven't already, use planetarium software to determine the elevation angle of Polaris from your location. Alternatively, you will find that the elevation angle matches the latitude of your location. Confirm that the location is indeed what you observe outside. For example, if you live in Los Angeles, Polaris will be visible about 34 degrees above the horizon in the northern sky. Honolulu, Hawaii is at almost 21 degrees of latitude, and the angle to Polaris will also be that angle low in the northern sky. If you live in northern Alaska, Polaris will be very far from the horizon, more than 70 degrees. If you live south of the equator, use a location in the northern hemisphere for the purposes of this challenge, since Polaris is near or most probably below your horizon. Before we continue, I'm going to quickly explain the basics of triangles and perspective. Vast amounts of further information on these subjects is just a quick Google search away, so I will not go in depth in this video. The further we get from something, perhaps another person, the smaller she will appear from our perspective due to angular size. Let's verify this with a right triangle calculator. There are many triangle solvers online. I chose this one for the example, and it is linked in the description box. With right triangles, if we know two things about the triangle, we can calculate the other things about it. For instance, if we know that we are 100 feet from a building and can measure the angle to the top of the building, we can calculate the height of the building. I'll put in 100 feet for the distance to the building as the lowercase b leg, and a 45-degree angle to the top of the building for angle A. Click on Calculate, and the program will display leg lowercase a, which is the height of the building, 100 feet. Now let's double our distance from the building to 200 feet. Since we know the building is 100 feet tall, I will put that in as the lowercase a leg and solve for angle A. Now the angular size of the building is about 26.5 degrees, which means that it will be smaller from our viewing perspective. We can do similar things with Polaris on a flat Earth model, since we can determine the distance from the North Pole to other locations on Earth, and can measure the angle to Polaris from our viewing perspective. To make this simple, your part of the challenge is to follow these steps for your location. Number 1. Determine the angle to Polaris from your location as described previously. Number 2. Determine the distance from the North Pole to your location using whatever accurate method you choose. Number 3. Put these values into a triangle calculator and report the results in the comment section of this video. I will go first to show you the method. The angle to Polaris at my location in Wichita, Kansas is about 38 degrees, which will coincide with the elevation angle of Polaris as discussed previously. Using Google Earth, I have determined the distance from my location to the North Pole as about 3,600 miles. Now I will put in the angle 38 into angle A and the distance 3,600 miles into leg B. Select to solve for leg A and then click Calculate, and you can see that according to our observations, Polaris is about 2,800 miles above the flat Earth. Please do the same and post the results in the comment section of this video. Please put where you live, the approximate latitude, the distance from the North Pole, and the distance of Polaris above a flat Earth that was calculated. When I receive enough results, I will create another video that plots them on a flat Earth map and also on a globe Earth. That's it for this challenge. I look forward to seeing your data. I'm already working on the next video, and I hope to see you there. Until then, I would appreciate any comments, likes, dislikes, and especially your subscription. Goodbye until next time.